Hello, everyone. Welcome to the Robin webinar. My name is Adish Phule, and I'm the Director of Products here at Robin Systems. And the topic of discussion for today is containerizing your existing enterprise applications. In some circles, they would also call it traditional enterprise applications or legacy. I personally don't like the legacy word, but these are key critical applications in your enterprise. So the agenda for the day is we'll start by setting the stage by describing what we mean by an existing enterprise application. So we'll discuss a few characteristics so we are all on the same page. Then we'll kind of talk about the current business and IT demands. So the enterprise applications have served us for a long time. Do we continue to keep those as is, or given the new needs, the needs of the current times, do we have to make any changes? Then we'll talk about containers. Now, since you have opted for this webinar, I presume you have some knowledge of containers. So we'll use that assumption and talk about how we can leverage. And that's where our next topic would be the path to containerization. So we'll discuss a few strategies. And then we'll talk about Robin, how Robin can help you in your journey to containerization and all the benefits that Robin provides, in addition to just the container format or the container engine. So that's our agenda for the day. So let's get started. All right, so what is an existing enterprise application? So if you look at a popular enterprise app, your CRMs or your ERP systems, and I picked the example of, say, Oracle Business Suite, which has been a popular product for many years, or many decades, I should say. Or even if you have built any of the custom applications, typically it'll have 3 tiers. It'll be either based on Java, .NET, or Ruby. You will have a notion of a large database server or a single instance database. You will have a large monolithic application server. And then many clients, whether they are web-based or whether they are mobile-based, etc. You would typically use libraries as components, and you would make in-memory function calls. So no notion of RESTful APIs talking to each other over HTTP or HTTPS. Many of the traditional applications were designed with scaling up, right? So vertically scaling versus scale out. So if you needed a performance boost, you would run that application on better, faster hardware, give it more CPU memory, give it better disks, move from regular hard drives to SSDs to all flash kind of a model. Now, if you contrast this with the current applications, they try to scale horizontally, so large clusters, multiple nodes. Now, that describes sort of the how the applications were constructed. But if you look at the operations side, almost each tier had its own specialist team. And you were typically deployed on different infrastructure. So for databases, you would typically try to be on bare metal because disk performance and performance was so critical for the application. Whereas your application servers, whether it's your JBoss or IBM WebSphere, WebLogic, you name it, would be virtualized. So they would run on one of the popular hypervisor-based virtualizations like VMware, KVM, Xen, etc. And each of these tiers also had their own tooling. So whether you want to take backup, clone, patching, etc., or you had processes around failover DR, etc. So specialized tooling and also specialized processes. So if a famous scenario used by in many of the presentations you might have heard is a person complaining that, hey, I asked for a database and it takes my company, my organization 6 weeks to deliver it, or my application deployments take 3 months. And the reason for that is that each team has its own policies, has its own processes, use their own tooling, and that's why you have to almost go step by step across each of these tiers and get those components. So that is our existing enterprise application. Now, they have served us really well for the last few decades, and some of the most critical data sits in these enterprise applications. So if you look at the changing landscape, if if you talk to any business and ask them what are their key goals, they would say we want faster time to market, we want to drive innovation, and we want to reduce cost. Excellent. They all sound great. But what does that mean to IT? Right? I mean, if you're an IT admin, you're wondering, or if you're an application admin, you're wondering, okay, what am I supposed to do here? And so some of the IT goals are, number one, to achieve faster time to market. Essentially what we're saying is we need to cut down the time it takes to move an application from dev to test all the way to production. Right? So we want to reduce the transition time, which means automation has to be at the forefront. We want to automate as much as we can. We want to automate all frequent operations like deployment, patching, etc. And finally, with the advent or the popularity of public clouds, anybody who is still on-prem or who has still a large data center footprint is essentially being asked to provide cloud-like experience on their on-prem infrastructure. Right? So that gives you the agility required to deliver apps faster to market. The second is driving innovation. Almost every company now has an analytical or insights group, which means they want to collect as much data as they can. They want to analyze it rapidly. You think of your stock markets, you think of your retail environments, etc. And all these, what that means essentially, you need exceptional tooling. I like the example of stock markets because when the market ends, you want to collect all the data from the day, whether it's trades or whether it's the transactions, and then you want to analyze and be done before the market opens the next day, right? So you really need that speed. And how do you get that? So you need orchestration capabilities which will deploy complex distributed apps, whether they are data pipelines or they are application stacks. You want the ability to rapidly clone your large databases, which has all the important information. So take rapid snapshots and rapid clones, and you want to give developers the freedom to choose the tools they like, right? Because only when you try to force them to use something they haven't used before, you hit the learning curve and you hit these delays. So instead, you want to give them the freedom to use the programming languages they want, the libraries they want to use, the tools they want to use, etc. But the last requirement, which kind of contradicts with everything we have said, is to reduce cost. So how can you be faster, better, and still cut costs? And that automatically means to IT that we have to do some form of consolidation, right? So I have to reduce my hardware footprint, I have to reduce my software footprint, and the only way to achieve that is consolidation, which is take one beefy server, put lots of apps on it, and hope for the best. But you don't want to sacrifice performance because that is not acceptable. And so another thing that you could undertake is start moving away from specialized SAN storages or specialized hardware and start using more commodity, because then you can really optimize for cost. So how can we achieve all of this? All right, so in comes containers. Now we have seen containers, and then when I say the word containers, a lot of people think about Docker, right? And yes, Docker is one of the popular formats. In fact, they made containers popular, but there are many other container formats out there. Something like native Linux containers, also known as LXC. There is Rocket, there is OpenVC, and so there are multiple container formats. And when you think about containers, think of a container format or a technology that best suits your application, and don't just use one of them just because they're popular in the market today. Again, as I said, I assume that you have some container knowledge, and so I won't go into a lot of detail, but if you want to learn more about that, there is a great 451 research webinar, and I have the link down here, and once you get a copy of the slides, you'll be able to access that. But if you just search for application-defined data center, that title there, you should see a great webinar which goes at length. So what's so great about containers, right? So containers have been extremely popular in the stateless space, mainly because, like I said, they give the developers freedom. You can use any libraries you like. You can use any of your programming languages, any operating systems, any databases, and you basically can define your containers by by breaking out a large applications into tiny microservices, and then each component of the service is included in one container. So unlike the old model where you had a large monolithic application server which ran pretty much every bit of service you needed, every bit of code that you needed, you are now limiting a single concern within a single container. So extremely powerful. What it also gives you is great mobility. So if you're using any kind of virtualization, and VMware is dominant in the on-prem space, but if you're trying to move to a public cloud, you will see the top 3 cloud vendors use Xen, KVM, and Hyper-V. And there is no VMware. So there is, of course, the migration cost and all the time required to do that. Whereas with containers, because they are supported, because it's almost like an OS feature, as long as that operating system, whether it's Linux or Windows, can be run in the cloud, your containers will just work there. So they have done great for stateless apps. But why not stateful your data-centric applications or enterprise applications? So these have largely been ignored, and it's only now that you see people trying to use the benefits of containers here. So if you look at the other class of applications, the non-stateless, containers can provide great benefits. They are lightweight, and they have zero performance cost because all the libraries they need are coming from the Linux kernel. So they are extremely efficient, extremely performant. What you can also do now is, because you're getting process isolation, you can have multi-tenancy on your bare metal servers, right? So you can run the same app, multiple instances of the same app on the same server without worrying about one interfering with the other. And of course, because most containers tend to be a smaller footprint of the OS, and they also, so a smaller footprint of the OS, you can get higher consolidation ratios, and you also reduce your OS and your VM sprawl. So lots of things good about the containers, about the whole container technology, which will help us leverage them for the non-stateless apps. So if you buy into that, if you say, okay, containers are really great, how do I start applying them to my enterprise apps? So there are a few strategies, right? So the first strategy here is why not not have an on-prem footprint at all? And I just list this for the sake of completeness, but why not just use a SaaS service? Let's not get into the headache of deploying a new stack on-prem. Let's just use a SaaS, which is a hosted service. I don't have to worry about infrastructure. Now, if you look at the graph on the right side, what I've done is basically it's a plot of effort versus the different options. And what effort really means is the development time, the testing time, and the deployment time, right? So if you were to use a SaaS solution, essentially there is no deployment effort involved on your operations team, but you may have a development and testing cost. And the reason I say that is, if you're using a CRM on an ERP system, it's highly likely that you have done some customization. You have built custom workflows, you have integration with other tools in your data center. And with a SaaS product, if it's the same vendor, they'll try to make it easy, the transition easier. But if it's another product, it's a third-party product, then you may not have that transition path, and you may have to rewrite those customizations, rebuild, that kind of stuff. The second option is go to your vendor, existing vendors, and ask them for a containerized version of the application itself. And a lot of the vendors are modernizing. So if you go to Docker Hub, you will see images, Docker images for IBM WebSphere application server, JBoss. You will see databases like Sybase, and Oracle. Even Oracle has published a bunch of Docker files which can be used to build custom containers for the database and for your middleware components, etc. So vendors are modernizing, and they are offering containerized versions of either the entire application or components that make up the application. Now, if I go to the extreme right, this is the other extreme, which is just rewrite the app, right? Like, let's ditch the current applications, just start from scratch. But as the chart shows, it can be quite expensive and time-consuming. So you have to, recode everything, you have to retest everything, and you have to deploy that. And so you have the responsibility for everything. And while it might be good in the long run to undertake such a project, what do we do in the short term, right? It's not going to happen within a few days or a few months. And so what do we do in that interim period? And that's where I like the last option, which is what I call as a lift and shift, which is essentially take your three-tier application, break it down into different components, whether it's the application server, database, the web server, messaging queue, whatever it is, break it down into individual components, and then containerize each of these components individually, and then deploy them as an application that spans multiple containers. And the benefit of that is your development time is minimal, because essentially you're retaining the same interfaces, and your testing time is again negligible, because all you have to ensure is that the different components can talk to each other properly, and they have the right networking and storage configured. And the only additional cost you might incur is in deployment, because now you're switching from your traditional bare metal or VM or all the custom scripts that you had written. You're moving away from that model to a more containerized way of deployment. So you might have to choose newer storage stack, maybe newer networking, virtualized networking, etc. But the way I think of this is now, if I have a collection of packaged apps and custom apps, and so which option is best suited for those class of applications. And as you can see, the lift and shift really works across both your custom apps and packaged apps, and it gives your existing applications a new lifeline, an extended lifeline, where they can benefit from containerization, but then you can retain the same application that you have had for the last decade. And this also buys you time if you're trying to re-architect that application. So essentially that's a good fit, and that's where I think it's probably one of the best options for your current existing apps while you undertake other initiatives. So this is a good time to take a poll. So I will pause, and what I'll do is I will open up a poll question, and if you can answer those questions. So the question here is, what type of enterprise applications do you have in your data center? Is it mostly packaged? Is it mostly custom? The custom build using Java, .NET kind of thing, or Ruby, or any of these programming languages, or something else that you have used. So somewhere on your screen, you should be able to access a area called votes from the audience, and you should be able to submit your votes. Yeah, and you have about 30 seconds to, actually you have about a minute to vote on this. So I see the votes are starting to come in, and looks like in the audience today, there is about an even split between packaged and custom apps, which kind of makes sense. I mean, you won't be building all the apps you need, and for some of the CRM and ERP kind of systems, you would probably look for a packaged application. All right, so thank you for your votes, and I'm going to stop this vote. And what I'll do is pose another question, which is, which vendors do you typically work with for your enterprise application? So I've listed like the top 4, and then if there are some others, you can vote for that. So there's Oracle, IBM, SAP, Microsoft, and others that you might be using. So this will give us a sense of what kind of applications we're dealing with. While you're answering poll questions, I'll just look at a few questions here that have started to appear. And I think the first question is a logistical question, is would we get a copy of slides? Yes, we'll post the slides at the end of this webinar. And the other question I see here is, does Oracle support containers? And that's a good question, because Oracle is known to be fairly traditional and conservative. So yes, if you go to their website, Oracle does support LXC containers for its database, and there is a well-defined support policy. And for many of their middleware components, they have they have exposed Docker files, and I believe they are also going to publish a Docker hub-like repository where you can just download Docker images for popular containers for popular products. All right, so thank you for your votes. I'm going to stop the poll now and continue with our presentation. Okay, so with that context set, let's talk about Robin. So what does Robin do, right? What is Robin, and why are we talking about containers and enterprise application? So if you look at the container space, what containers do really well are, number one, they help you package your dependencies and your software in a single image format. So it's easy to deploy, and the operations team doesn't have to worry about installing those libraries and satisfying those dependencies. The second thing it does is you can run these containers within their own isolated processes. So they give you process isolation, and that's great. So you now don't have to worry about multiple applications trying to conflict with each other. But outside of that, if you look at it, as we discussed, a typical enterprise application would span multiple hosts. So it needs good networking, multi-host networking. Since database is a major component and pretty much your performance is driven by the database, you need good storage. And you also need orchestration because these applications are kind of complex to deploy. So many moving parts, and they have to be sequenced and all of that. So what Robin does, essentially, it is an application-aware, software-defined infrastructure, right? So essentially, it is a single software binary that includes container-based virtualization, or it uses container technology. It provides, again, a software-defined scale-out block storage, and I'll talk more about this. It offers virtual networking and orchestration both for the application and for the infrastructure. Right? And on top of this, you can run all kinds of apps, your big data apps, your database, your regular traditional databases, or your custom applications. And the goal for Robin essentially is, number one, to simplify application management. Right? So it's very easy to deal with one tier of the app. Let's say I am a DBA, I only deal with database. I am a middleware admin, so I only deal with WebSphere or Tomcat or JBoss. And so it's very good. But how do you start dealing with the entire stack? Which means if I want to clone my enterprise application, how do I do that using disparate tools? And that's the kind of problem we are trying to solve with Robin. So simplify application management, guarantee performance. If you have ever tried to consolidate your environments, you need performance guarantees. And the third is, how do you improve utilization of your current infrastructure? All right, so let's kind of peel the onion and see what's under the covers here. So let's say you have your existing commodity hardware, and the hardware has some supported Linux operating system running on it. So you come in and you deploy the Robin binary, and what you get with this Robin binary is a container-based compute plane, a container-aware block storage plane. Now this is, as I said, scale-out block storage. What that means is you can take a bunch of compute servers and you can take a bunch of servers with disks, and you can create a storage cluster and a compute cluster out of it. You can even have a converged configuration where compute, store, disks, everything is all together in one box. All right, so you have these kind of configurations, and you can keep on adding as many servers as you like, and you get a linear increase in capacity and performance. Okay. Now the second aspect is block storage, and that is important because based on the application and the file system that you want to use, whether it's ext4, whether it's XFS, or if you're running something like Oracle and you want raw disks for ASM, Robin will provide a solution for you, and that's where Robin is able to carve out blocks of storage volumes essentially, which get mounted onto your containers, and then you can format it to any file system that you like or leave it raw. And then to glue both of these together, essentially we have a fabric controller, or the management or control plane, which will do application infrastructure orchestration, will give data lifecycle QoS guarantees. So we'll talk more about that in subsequent slides. All right, so once you have this platform deployed, what benefits do you get? So number one, as I said, is we make application management simple. So the lifecycle of the app, whether it's initial provisioning, scaling, taking snapshots, doing clones, or doing restorations is fairly simple, right? So the lifecycle of the application is reduced to a few clicks. Second is we have a dynamic real-time quality of service policy, which allows you to allocate resources to your applications and change them without modifying the application or the application configuration. And the third thing is becomes an excellent platform for consolidation. Now, when you combine all these features together, I'm coming back to the business demand slide here. All right, so we said that given the new business needs, IT has certain goals in mind, and Robin is really focused on solving those goals or achieving those goals for IT. So the first goal, as we said, is faster time to market, and essentially how Robin addresses that is by providing a push-button deployment for the entire stack, right? So like I said, 3-tier stack or N-tier stack, and Robin will help you deploy the stack in its entirety. What you also get is integrated app and infrastructure management. So if you look at any of the analyst reports, they'll tell you that infrastructure is a major reason for delays in application deployment and for issues with application uptime. And so only when we bring infrastructure, only when we tightly integrate app and infrastructure, and only when we have flexible control over the infrastructure, can you truly speed up your application lifecycle management. And what Robin also gives you is cloud-like agility on top of bare metal. So we are giving a new life to your bare metal servers. We are making them more mobile. We are making them more versatile. In terms of innovation, especially if you look at like the NoSQL space, there are new products coming out every day. There are messaging bus, there's Kafka, there's Cassandras and Mongos. So there are data pipelines and Hadoop systems, and so there are data pipelines, and there are also traditional, BI kind of tools, which have again the stacked, 3-tier architectures. So these two are very different in nature, and so what we want is a solution, and Robin provides this solution to deploy, orchestrate across all these different components and across all these different stacks. What Robin also provides is rapid ability to take snapshots clones for the entire stack, and because we're using containers, we give developers the freedom to use whatever software they feel most comfortable with. In terms of reduction of cost, because of our QoS policy and our isolation that we provide, we can help you reduce your hardware footprint by more than 50%. And that is a huge saving. And the way we can achieve that is, typical utilization on any server is not 100%, so it's very difficult to get that kind of a load profile. And so, we are able to provide with our isolation the ability to deploy multiple apps on the same physical server and ensure that they don't compete with each other for resources. So you get guaranteed performance and higher consolidation. And of course, with the lower footprint of the operating system, you can reduce your VM and OS sprawl. All right, so with those benefits, let's see how Robin is able to deliver all of this. And I started the Robin presentation by saying Robin is application aware. So how do we do that? So to define an application as Robin is extremely simple. All you have to do is describe what the application needs in terms of maybe container images, in terms of the storage, the number of volumes, the compute resources, or any custom scripts or hooks that you want to run as part of the application, either post-creation or before start-stop, a snapshot, clone, basically any operation that Robin supports, you can plug in your custom hooks. And so you define all of this metadata about the application in a simple YAML file, and that's all Robin needs to kind of kick off an application. And essentially, since we say a typical enterprise application can have multiple tiers, so you can define each of these tiers in this simple YAML file, and you can also define dependencies across these multiple tiers. So let's say if you first provision a database, then you provision your application server, and then you say I want to configure a data source, so you can automatically fetch the database details and have us auto configure the application for you. All right. So once you define these manifests, you can do multiple of these. You simply import them into Robin, and you can now visit our application catalog and see the various applications that we support. So out of the box, we support a lot of the popular applications, whether they are Hadoop systems, whether they are NoSQL or your enterprise applications. And I'll show you a demo of one of these applications today in today's webinar. All right, so let's dive into a few demos. So what we'll look at in our first demo is, let me switch to my screen share here. And okay, so there you go. So let me switch to my screen share here and kick off a demo. So what you're looking at is the Robin user interface. And what I'm showing you on the screen is the application catalog. So we have a bunch of applications that we support out of the box, but if you need something else, you can easily build it using the YAML file that I described just a minute ago. And so for today's demo, we'll essentially use the Oracle stack. So what I have here is a simple medical records application being deployed on Oracle database and Oracle WebLogic server, right? So I have one instance of Oracle database here and the WebLogic admin server. And what I've done is, for Oracle, I'm using LXC containers because that's what Oracle formally supports for their production environments. So for the database, I specify some CPU memory storage, and similarly for WebLogic, which is a Docker container that we built in-house. So I have uploaded that image to my local Docker registry here. I have specified some CPU memory, some storage in terms of the volumes that I need, so my configurations are persisted even when I bounce the container. And then using our sort of templating language, I'm fetching the host name of the Oracle database once it's provisioned, and I'll use that to configure our data source. All right, so very simple inputs. Realize how at no point did we have to run create volume or create network, right? We never ran those commands. It's all declarative. It's all in the manifest, and it's being provisioned for you at at deployment time. So I'm happy with all the inputs that I've provided so far, and what I can do is simply provision this app. So I will go click on provision, and a job will be kicked off, which will, so another thing that I've configured in my manifest is to make sure that these deployments are serialized. So I first want my Oracle database to be created, and then the WebLogic configuration. All right, so we clearly accelerated to that part since we don't want to wait on the webinar. So my provisioning is complete, and as I look at my my completion screen, I see that there's an application called MO1, which has 2 containers. Each container has its unique host name and IP address, so you can connect to these, ping these servers directly. And there are 2 storage volumes provisioned per container. I could have done more, but I'm happy with that. And I can verify this from my terminal. So here I am on the terminal, and I first check my LXC container. And the beauty about LXC, and the reason why Oracle supports it, is you can just SSH into this container and do operations just like you have done before. So if I don't tell you that you're running in a container, you would think it's a physical server or it's a virtual machine. No difference. And so here I'm checking that my database is up, and I see the process that's running. I can connect to SQL Plus and verify that my database is indeed open for read-write. Similarly, I look at my Docker configuration. So I see that a new container has been provisioned. It's been up for a few minutes. And then because for my Docker container, even though my container comes up, the configuration of the application server and deployment of the app takes a few minutes. So I can now look at the Docker logs and confirm that indeed everything worked. I click on the URL, and that's my medical records application successfully deployed. All right, this is all great. If you have used application server, they would typically have an administration console. And so here I'm connecting to that console, and I can see the one data source that has been defined for my app, and that is the the URL that is referenced for my Oracle database. All right, so that is how easy it is. So let's go back to the slides here. Okay, so that is how easy it is to deploy an enterprise application on the Robin platform, right? And for this webinar, we are talking about enterprise apps, but this could be your microservices-based app, or it could be your distributed clustered database, anything you like. Okay, so all right. So before I move on, let's do another poll. All right, and if you could respond to this poll, and the question this time is, what is your current container adoption? Are you familiar with it? Are you just exploring? It is actively being used by your developers, or it's already deployed in production? So that will help us understand our audience a little better. So if you could start, once again, if you find the area on your browser where you can start responding to the poll. Yeah, so there's okay, so we see answers starting to come in. So thank you for responding. I'll keep the poll open for another 10 seconds and then move on. So I see a lot of people saying that they are just exploring or playing with containers, which makes sense because this is a topic where containers have not been used a lot for enterprise apps, and that's exactly what we are trying to do here at Robin. All right, so thank you for responding, and let's move on. All right, so we saw how simple it was to deploy deploy our application on the Robin platform. But Robin is doing a lot of heavy lifting behind the scenes. So number one, it's doing container placement, is doing storage provisioning, is doing network configuration, all of that for you. In fact, if you want protection for your data, you can also set up replication and data protection policies. And all of that is automatically taken care of by Robin. But Robin also provides failover support. So if you have a container running on a physical server, and if the physical server were to get, if it were to incur a failure or some kind of a fault, we can seamlessly move that application onto another healthy server, right? And what the beauty about the Robin platform is, we can retain the same volumes, the same IP addresses, the same identity of the container. And so from an application perspective, all you will see is a tiny blip of few seconds, and then the application stack is back up working as if nothing had happened, right? And this is an exceptional ability. And where you can utilize this, and we can do the same for disks as well. So if we discover that there's a disk failure or any kind of data corruption, we can automatically address that and do disk repairs automatically for you. Now, where this kind of capability is useful, so failover is one scenario. This kind of capability is also useful when you're refreshing your hardware. So let's say you're getting rid of your old hardware and buying into some new beefy servers. You can easily add them to the Robin cluster, and then within a single click, just migrate all your existing containers or apps that are running on that server onto the new server. And so it's an easy way of either rebalancing your cluster or refreshing to new hardware. Now, Another benefit of running on the Robin platform is you get to version your application and your data. So let's play a scenario because it's easier to understand if you just walk through a scenario. So let's say I have a production application. It's a 3-tier app, so I'll show you the icon with the 3 blocks here. So there are 3 components, your app, web, and database tiers. And now, as you make changes to the application, what you can do on the Robin platform is take snapshots at appropriate times. And these snapshots are not the typical volume snapshots that you get from the other storage vendors. Basically, this is a snapshot of the entire operating system, the entire app software, so the binary, the configuration, and any data in case of databases that's stored within the application. So it is a true application snapshot, right? So it's capturing the current state of the app. And now what you can do is, as you make changes to the app, you can literally capture these changes via periodic snapshots. So you're literally versioning your application and keeping different point-in-time copies of it on the platform. Now let's say you want to test a change. And a typical change could be you're trying to change the schema, or you're doing an application upgrade. You want to test an application upgrade, or you're trying some deployment, undeployment kind of actions. So clearly you don't want to do this on the production app. And so what you can do is, with a single click, create a virtual test bed or a virtual test application and perform the same operations. And the benefits here are you would not incur, so it's not a full clone of the application, so it's space efficient. It's using copy on write kind of technology. And so it's space efficient and it is time efficient because it takes just a few minutes to take a clone of even a terabyte size database or a large application like your SAP or your e-business suite. And all of the configuration is all automatically being handled by Robin, so you don't have to worry about that either. So you now get your test cluster and you start making changes to the test cluster. Meanwhile, the production app moves on. Now let's say your production app incurs a data loss or a corruption, and now you want to rescue this application. So once again, what you can do in Robin is a simple restore operation where you simply, using a simple slider, you can say restore back to this well-known point-in-time copy of my application, and we will bring all the configuration and the data back to that point. So enough slide work. Let's look at another demo where I can demonstrate clone and restore to you. So once again, let me switch back to my demo here. And I'm going to stick with the same application, but this time what we'll do is we will take a snapshot of this application, as I said. So let's say I'm trying to upgrade my application. So all I do is go to the Robin interface and say, let's capture this and call this snapshot as snap1. So it's a rapid snapshot, and as I said, it captures everything right from the container to the OS to all the way to the data. So there, my snapshot is ready, and now I am free to make any kind of changes that I like. So what I'll do here is I will do a destructive change. So I'm going to go and delete the application itself. So I'm undeploying my Medric application, which is the medical records app, and now you can see that it is successfully removed, and if I refresh my page, I get a 404. So there, the application is gone, right? This is a catastrophic situation, not something I desired. So let's save the application. So I go back to my snapshot and I say restore. And restore incurs a small downtime, but since our application is already in a bad state, that shouldn't matter. So now all we are doing is moving the application to a well-known snapshot, which we took before making the destructive change. So that is successful. So now I can go back to my application, do a refresh, and I should be able to access that URL again. There, my web application is back. And if I switch to my admin console and refresh the page here, so there I go back to deployments, and there I see that my Medric application is back. Now, as I said, we made a change to, this could apply to upgrades, it could apply to any changes in the database itself. So if I were to drop a couple of tables or a couple of columns or rows, I would be, the restore operation would revert those back in time as well. So that's the first time travel feature, like snapshot and restore. Now the other thing you can do with your snapshot is to take a clone. Now I want to clone my entire enterprise app, and that is extremely easy in Robin. All you do is give it a name, choose which resource pool you want to deploy to or which cluster you want to deploy to, and that's it. Robin behind the scenes will provision, do the network configuration, provision volumes, provision containers, everything for you. And cloning typically is a much faster operation since, the volumes already exist. All you're doing is creating a thin clone and remounting them. So there. So my clone is ready. First, Robin tells us that it was cloned from this snapshot, so you know for, in future if you have to come back and verify, You will again see two containers, each with their own unique IP addresses. So I have 83 for the database and 253 for the Dockers, for the WebLogic, and I have two new volumes, which are clones of my existing app. And so if I go to my terminal, I now see that I have two LXC containers, two database instances running, and then I have two WebLogic instances running as well. And as it confirms, it was provisioned about a minute ago. So I run logs. Logs tell me everything is successfully provisioned. So now let's access the new app. So as I said, the IP address is 253, or the host name has 253 in it. So let's revert to that URL. So the application loaded, but the truth is in the admin console. So now we'll go to the admin console, look at our data source, and we'll see that our data source has also been updated with the new database or the clone database. All right, so that's how easy it is to deploy an application and take snapshots, do time travel, and clone of the full stack. That's the important thing here. There are many tools which will just do the database, which will just do the web server, app server, but Robin goes across the entire app, will snapshot clone the entire application. Okay, so now let's go back to our slides. All right, so one of the marquee features of Robin storage, and in fact, as I like to call it, sort of a prerequisite for any form of consolidation, is performance guarantees. So let's say you have one application today running, or one database running on a physical server. You have dedicated the entire I/O resources, the entire CPU memory, etc., to that app, and there is nothing to compete with it. So you get excellent performance, you get predictable performance. Now let's say you were to run another application because you realize that your utilization is only about 40%. So you say, let's run another app, or let's run a clone of that very app. Now, unfortunately, there is no way for you to tell the infrastructure that, hey, one of my apps is of gold class, whereas the other is of bronze class, or one is more important than the other. And so soon, what you will see is these two applications will start competing for resources. Now, using containers will give us process isolation, so you're protected on the compute side, but on the storage side, on the disk side, there is still no help. And so your performance will suffer across the two applications. And if you keep on adding more applications, more and more containers on the same server, you will start running into what is typically known as a noisy neighbor issue. So you'll see some applications come in, they hog all the resources, while the others really suffer and get nothing out of the disk. And that's where Robin comes into play. So Robin provides a quality of service policy which lets you define the resources that should be available to the entire app, right from the CPU cores to memory to read IOPS to write IOPS. And you can also set priorities between the different apps. And this will ensure that when such a policy goes into effect, it will essentially ensure that first you get isolation between the two apps. So my bronze class will now not hog all the IO resources, and then my gold class gets will get everything they desire. Now, once you have such a robust QoS policy, what you can also do is dynamic real-time scale up and down. All right. So if you look at the panel on the left, the little screenshot on the left, that's a screen from the Robin product. And essentially what it shows is that I have an application running and I have certain resources allocated. Now let's say the performance is not as great, or let's say I have a bad job running between 2 and 6, and I want to give a temporary boost to my app. So how do I do that? So one is I can give it more CPU memory resources, and I make my containers larger, or my app suddenly has more compute resources. But that may not solve the problem, especially if you're dealing with databases as part of your app hierarchy. And so for databases, you need control over IOPS. And Robin will allow you to do that as well. So I can simply go and with a slider, give my applications more read and write IOPS. And now you will see faster performance from the database as well. This again is an extremely powerful feature because unlike the modern applications where scaling out is native to their nature, for most of the classical traditional apps, you want to scale up. And so with Robin, you can make these changes dynamically without having to change any configuration on the application side. All right. So let's see a demo of this as well. This feature is best demonstrated via a video here. So what you're looking at is two workloads. So this is the Robin interface, and on the left side we have list of apps that have been deployed, and on the right side we now have the infrastructure view. Now just because Robin manages both infrastructure and application, we can show you both sides of the coin here. So I'm looking at my read IOPS currently, and you see I have two applications, red and blue. Both of these are databases, but it could be essentially any application that's running on Robin platform. So now what you see is the condition I described earlier. There is no QoS policy in place, and so the two applications are sharing or have split the I/O capacity across, have shared the I/O capacity evenly. So this is clearly not desirable. Let's say my blue application is more important. And so what I do is I go to the red application and reduce the maximum read IOPS allocated. So I have set this to about 6,000. And if you watch the graph on the right now, instantly you will see a decrease in the IOPS being consumed by the red app, and blue is able to use up more. So you have given your blue application an instant boost by giving it twice the amount of read IOPS, or a large amount of IOPS. Now here is another scenario where I have three applications running, but clearly the green application is hogging all of my resources. So once again, this is not a desirable state because my blue application is suffering. So I could deploy the same strategy as before. I could set the max limit and reduce the IOPS available to the green app. But what if a fourth application comes in and does the same? So instead, I'll use a different strategy. So I will go to my blue application, and now instead of the max limit, what I'll do is set a minimum limit. So I will say no matter what, or no matter where you run my container or my application, make sure it always gets 19K IOPS. And what you will see now is instantly the red and the green have reduced proportionally, and the blue application gets about 20K IOPS. And that's how simple it is to control the I/O bandwidth, or that's how simple it is to give additional resources and take them away from your application. All right, so coming back to slides here, and we are almost towards the end of the presentation here. So let's summarize what we saw today. Right? If you look at your current state, you either have to choose between best performance, in which you get poor consolidation, or you have to choose best utilization, in which case you are sacrificing performance. So it's an or. With Robin, we can give you best performance and utilization of the server by giving you performance isolation for your app. Right? Secondly, with Robin, application management, basic lifecycle operations become extremely simple, right? And this is again across the entire stack, not at an individual component level, but across your entire, typical enterprise app. We can also control performance. So the predictability part of performance is more important here, and that's where by setting a minimum guarantee for your resources, you can ensure that no matter which server your application runs on, even on after a failover or a rebalance, the app gets what it was designed to get. The next point is, as I said during the demo, at no point we had to call up an infrastructure admin, or at no point we had to run create volume, create network, none of that, right? And so that is the whole motto of Robin, is that we want to make application deployment management simple and make infrastructure invisible, right? So as an app admin, this is like nirvana. You don't have to call up your admin and request for additional resources or get that volume or chase a ticket, all of that. And then finally, while IT gets all these, these controls and all these features, you're still giving your developers freedom to do what they desire. So they can choose, Perl, they can choose modern languages, Go, whatever they want to use, the libraries they want to use, the operating systems they want to use, complete flexibility in what they want, as long as it goes and sits inside a container, and then you can easily deploy these containers as an operational or as an IT team without having to worry about dependencies, right? And the beauty about this is once you run the application, complete application on the dev platform or within the dev environment, the same exact thing can be replicated in production as well. And Robin is that single platform which will guide you or guide your application all the way from dev to test to all the way to production. Okay? And that is the power of the Robin platform. So with that, I conclude the slides. Let me take a look at the questions that people have asked. And yeah, feel free to type in more questions. I'll be happy to answer them. We have a few minutes. And if I cannot, we'll follow up over email. As I do that, I will also open up a poll question to just better understand the audience that has attended this webinar today. So, all right, so one of the questions here is, how would, this is an Oracle-related question. So in Oracle 12c, they have a new feature called pluggable databases. So the question is, how does this work in backend? Okay, how will this containerization work in case you're trying to use the new Oracle feature of pluggable databases? So there are actually multiple benefits to using Linux containers over Oracle containers. Number one is, as I said, you get complete isolation across the different databases. Whereas in pluggable databases, you have a lot of dependencies in terms of how you start these containers. So let's say if you take a very common example that I have to apply a patch, that means I have to bring down the entire container, the entire larger database and all the pluggable databases along with it. So a container strategy within the database is inefficient because the lifetime of all the pluggable database is tied to the outer container database. Whereas if you go with the Linux container route, the Docker, the LXC route, essentially each application, each database is on its own. So if you need to patch that database, you just bring it down, apply the patch, and bring it back up, and none of the other applications that are being supported by the databases are impacted. Now you can very well run PDB configuration within a single container if you desire so. So there is nothing stopping you from doing that, but there are benefits to just sticking with the regular databases and doing it. But like I said, we support both. So hopefully that answers your question. Another question that is being asked is, how is OS licensing impacted when using containers? So I believe the notion of containers, whether it's Docker or LXC, basically it's just a feature of the operating system. So for Red Hat, at least, or most of the popular OS distributions, there is no additional cost incurred in using containers. In fact, my best example is that starting kernel version 3.8 or so, the Linux operating system runs within a container by default. So think of it this way. By default, if you're using Linux today, let's say anything Red Hat, CentOS version 7 above or Ubuntu, you are already running in container 0. All we are doing on the Robin platform is creating container 1, 2, 3, 4. So there is no additional license cost incurred, and there is no additional performance penalty incurred either. Okay, so all right, so I am going to close the poll out which we had on storage. So that concludes our demo. If you have any other questions, feel free to post them now or reach out to us via email, and we'll be happy to do follow-up. Also visit our website. The website address is on the slide there, and the email address is on the slide there as well. So feel free to reach out to us or share the replay of this webinar, which will be posted within 20 minutes of, I think 20-30 minutes of completion. So thank you all. That concludes the webinar. Thank you all for joining and spending time with us. And hopefully you had you learned something, and you have, like I said, if you have questions for us, feel free to reach out. Thank you very much. Have a good day.